Hi there, and thank you for finding my channel. This video is quite simply about the 4 different types of transformations. We're going to run through examples of each. I hope you find something useful here. If you do, as always, please do subscribe and like. Thank you. So what is transformations all about? Well, the word transformations is really just a blanket heading for 4 different skills that we're going to have to be able to demonstrate. The first of those is translations, then we have rotations, reflections, and finally enlargements. And I'm going to go through these in this order. So let's make a start with translations. If you are translating a shape on a graph, then you are simply moving it. You are sliding it in a direction, and that direction is given to you by use of a vector. You don't turn it in any way, it doesn't change its angle, it simply moves. So here's a typical question that you might get. You are given a shape and it may say translate this shape by the vector 12 minus 6. Occasionally you may be told that your original shape is A and you have to label your new shape B. So we're translating it. We are moving the whole triangle by the vector. You would start by choosing one corner of your shape here. I'll use the top point of the triangle here, and let's move it through the vector. So the vector is 12 minus 6, so we are going 12 to the right, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and minus 6, so 6 down, 1, 2, 3, 4, 5, 6. This means that the top corner of our translated shape is going to be here at 1, 3. You can do a couple of things now. You can either simply look at the lengths of the sides. In other words, this left hand side is 1, 2, 3, 4, 5, 6 squares. So you can count down 1, 2, 3, 4, 5, 6, which puts that there. Or you can copy the translation. You can take this bottom corner and translate it through the same vector. So you would go 12 and 6 and come to the same place. The bottom line of the triangle similarly is 1, 2, 3, 4, 5. So I'm going to count on 1, 2, 3, 4, 5. Again, you could simply take this bottom corner and translate it through the vector. Once you have the 3 points of your new triangle, all you need to do is join them up, and you have successfully translated the triangle from position A to position B. Let's do this again. Let's now translate the new triangle. So now we're being asked to translate B by the vector 6, 5. So we go again, but this time our starting position is B. So from the top corner again, I'm going to count 6 on. 1, 2, 3, 4, 5, 6. This time the lower number of the vector is a positive, so we're going up. 1, 2, 3, 4, 5. My top corner is now going to be there. And again, I know the left hand side is 1, 2, 3, 4, 5, 6, so I can draw the bottom. And the bottom is 1, 2, 3, 4, 5, so I can draw that. We're going to label this C, and in exactly the same way we're going to join the sides. So I've now made 2 separate translations. Now something else that you can be asked here is to describe a translation. So your final question may be, describe the transformation that maps C onto A. Well, the first thing you're going to do is to say this particular transformation is indeed a translation. We are simply moving the triangle. So your answer would be, it is a translation. And then you have to give the vector of the translation. So same story again. We're going to start from the top of C. We're mapping C onto A. So from here, to get to the top of A, we have had to go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now 18 takes us to here, so that would be minus 18. We're going to the left, and then we had to go 1 up to go back to the original point here. So the translation is minus 18, 1, and that would be your answer. So don't forget, translation, you are simply moving, no turning, nothing fancy, just a straight movement through a vector. Our next transformation is a rotation. Now before we start putting shapes on here, let's just have a look at this. Rotation, so we are turning something round and we are given a point about which we rotate, the center of the rotation. Now let's just think for a second. If we have a line going up the page here, then we are pointing north. If we are going to rotate something 90 degrees, that means it's going to end up pointing in that direction. 180 degrees is round to here, 270 and 360. The question can, however, ask us to rotate in both directions. Therefore, we can also have from the top a 90 degree this way, or following right round to the half circle for a 180, 270 and 360. So be careful you know how many angles you are rotating it through, and is it clockwise or is it anti-clockwise. Let's continue with triangles for the time being. This time we are going to rotate, and a typical question here will be to be asked to rotate this triangle 90 degrees about the origin. Now it's interesting here, you often find in an exam you get a piece of tracing paper to help you to do this, and the way you would do that is to put your tracing paper over the shape and the origin here. You would draw the shape on your tracing paper, put the point of your pen or a compass on the origin, the point of rotation, and you would physically turn the tracing paper 90 degrees and then redraw the triangle in its new position. I haven't got tracing paper here, so let's have a look at how we would do this. We are going 90 degrees, so we are going to be taking our triangle from this quarter into the quarter here. Now, let's take a point on the triangle, let's say the bottom right hand point here. If we have a look at where it is, it's again all about counting boxes. To get from the origin, we would go back 3 and up 1. Now, if we turn that 90 degrees, this movement back 3 here would turn round and become 3 up. We've moved it 90 degrees. Similarly, this next step, which is up 1, would move 90 degrees and would move to here. So what we have done is we have taken this point and rotated it so that now it is sitting in its new position, which is just here. Let's have a look at the end corner of the triangle here. This has gone 10 to the left and 1 up. So by turning it 90 degrees, we would have to go 10 up here and 1 on. We are simply copying this movement, but we're taking it through 90 degrees. Let's have a look at the final, well, let's mark that one in blue. Let's have a look at the final corner on the triangle. Now this, from the origin, the point of rotation, it is 3 back and 4 up. So we are going to go 90 degrees around, 3 up and 4 this way. We are copying, but we are turning the movement through 90 degrees. So the third point on the triangle is going to be here. If we then join the points up of our new triangle, we will find we have a triangle which has been rotated exactly through 90 degrees about the origin here. It has been spun around. Now let me take this back a step, because it's not always the case that the origin is going to be the point of rotation. Let's change the question slightly. We are not now rotating around the origin, we are going to rotate around the point 1, 1, which I've indicated here. Now this means we're no longer looking at 0, our point of rotation is here. Let's have a look at the triangle again and pick a corner, this bottom corner here. Now we are now looking at the movement from the new point of rotation here across to this bottom corner, and we can see that it's gone back 1, 2, 3, 4 squares. and then it hasn't moved. So if we take that motion of 4 squares and we move it 90 degrees, it's going to become 1, 2, 3, 4 squares in this direction. Let's have a look at this point on the other end of the triangle. This has gone from 1 to minus 10. It's gone 11 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore, from here, again, moving it 90 degrees, it has to go up 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 just fits on my paper. It's at the very top here, up at 12. Now let's have a look at the third corner of the triangle here. To get from our point of rotation, we are going 1, 2, 3, 4 back, and then 1, 2, 3 up. So again, 90 degree rotation, it's going to be 1, 2, 3, 4 up, and 1, 2, 3 to the right, which puts us here. Let's once again join our triangle. We can see it's in a different position to the one where we rotated it round the origin, because we have now rotated it through a different point. In an exam, the point of rotation often is the origin, but not always the case, so you need to be prepared for it being in a slightly different position. If you can use tracing paper, it can definitely make this question easier. The other difficult one is you are given these two triangles and asked to find the point of origin. And the only way to do that really is to say, okay, how has it been moved? Well, it's been moved from here up to here. Therefore, the point of origin is going to be somewhere in the center here. And literally use your eyes to play around to find points that might make sense and try them out. Not an exact skill and not as common a question. So the third in our series of transformations is a reflection. Now, a reflection is exactly what it sounds like. We have to imagine for this particular skill that we are using a mirror. And we are going to draw a copy of this shape, I'm sticking with triangles again, as though it were reflected in a mirror. A question will tell you where the mirror is. So, let's assume that this particular question is asking us to reflect the shape in the y-axis. So this is telling us that the y-axis is where we are going to put our mirror. Let's just highlight the y-axis there. So we are reflecting this, which means you have to imagine if you are looking in a mirror, here is the shape in the front of the mirror. What will the shape look like on the other side? Similar to other translations, we look at the corners of the triangle. Let's take this bottom right hand corner again. All we need to do is count how many squares we are away from the mirror. In this case, 1, 2, 3, 4, 5. It's therefore going to go up 1, 2, 3, 4, 5 to plus 5. Similarly, we go up to the top corner of this triangle, and on y equals 9, we are again 1, 2, 3, 4, 5 back. So we go 1, 2, 3, 4, 5 forward. We're building up a reflection. The third and final corner of the triangle on the y equals 2 line here is back at minus 10. So we're going to go up to plus 10. And as with previous transformations, we then link the three corners of our new triangle together, and we can see that it is indeed a reflection of the original one. Now let's do another one, because very much like in the previous transformation, we are not always asked to use the x or the y axis. So again, let's change this question ever so slightly. We are not going to use the y-axis this time. We are going to use the line x equals minus 2. So let's this time highlight x equals minus 2, and it's going to be this line here. So now what we've effectively done is moved the mirror closer to the original shape. But we're going to follow the same process. This bottom corner is now 1, 2, 3 away from the line, so we're going to move 1, 2, 3 in the opposite direction. Don't forget we're using this line now. The top corner is 1, 2, 3 away, therefore we're going to move 1, 2, 3 in the opposite direction. And again, from here we're counting back 1, 2, 3, 4, 5, 6, 7, 8 squares, so we're going to go forward 1, 2, 3, 4, 5, 6, 7, 8 squares, and our third point of our triangle is going to be there. Again, collect the lines, and we can see that we have indeed created a reflection, but this time it's not about the origin, it is about the line here at x equals -2. You can see the line is in the center, exactly in between the two triangles. Now one more example, and for this third example we are being asked now to reflect the shape in the line y equals x. Well, first of all, let's draw the line y equals x. If I start at 10, 10, it goes through the origin and we'll go down to -10, -10. So now we have a different issue. The line is not vertical or horizontal, but we need to use this line as the mirror. The coordinates do help us for this particular line, because what we can do is look at the coordinate of each of the points of the triangle and we can swap the numbers round. What I mean by this is if we look at this bottom right hand corner, it is at -5, 2. So if we use that and switch them round, the actual coordinate of the new triangle is actually going to be at 2 -5. Let's plot that. So 2 -5 is down here, so that's going to be our first corner. The second corner, let's use the top one here. Well, this is at -5, 9. Therefore, let's do the same again, swap them round, and we will end up at 9 -5. So that's going to be the coordinate of the next point on the triangle. So let's go 9 and then -5, which puts the corner there. And finally, our third corner is at -10, 2. So let's swap that round. That becomes 2 -10, and that's going to be our third corner, which is 2 -10, which puts it down here. Let's join up the corners of the triangle and make our reflected shape, and there we have a triangle that is reflected on the line y equals x. And again, if you tilt your head slightly and look at the picture, you can see that the line of reflection, the mirror line, is exactly in between the two triangles. And finally we move on to the fourth and possibly the most tricky transformation, and these are enlargements. There are two pieces of information that we need to know in order to carry out an enlargement, and the first of those is the center of enlargement. What this means is we're going to be given a point on the graph, and that will tell us where the enlargement is going to grow from. You'll see what I mean by that in a couple of minutes. The second piece of information is the scale factor. Now that's going to tell us how many times larger, or in some cases smaller, the new shape is going to be compared to the old shape. Now for this example, what I'm going to do is make the center of enlargement the origin. So it's going to be at 0, 0. So let's put a little cross here. The scale factor is going to be 2. That means each side is going to be twice as long. So the bottom side here is 2 squares. In the new triangle, it's going to be 4 squares, and so on around the triangle. Now, to start an enlargement, what we need to do is draw some more lines. And these lines go from the point of enlargement, which, as we said, in this case is the origin, and we take that line through each of the corners of the triangle. This needs to be done accurately to make sure we have an exact drawing at the end. So as you can see here, this corner is at 4, 1. I've made sure the line goes through 8, 2, so we are accurate. Similarly, I'm going to go through from the origin another line through the top corner here. Again, it goes through 2, 4, so I'm going to make sure that my drawing goes exactly through 4, 8 here, so that we have an accurate line. You will find it easier on paper with a ruler. I'm also going to take a third line again from the origin, and I'm going to go through the bottom corner here and straight through. This goes through 2, 1, so I'm going to make sure it's going through 10, 5 there and there. Now, if you look at what we've got the center of enlargement. The enlargement is starting here, and what is happening is it's as though the diagram is traveling in this direction. We are going to draw another triangle on this side using these lines, which is going to follow the scale factor of 2. Now, not only does the scale factor tell us that the new triangle will have sides which are twice as large, it also tells us that the new triangle is twice as far away from the origin. So we need to take into consideration each of the corners, where they are in relation to the origin, and double the numbers. Let's try this now. Now, with a graph on paper, if you have a ruler, you can in fact use a ruler to do this. If I move this ruler so that the 0 is exactly on the origin there, and then I turn it, let's have a look at where the bottom corner of the triangle is there. You can see that the bottom corner is at 33 millimeters. If I double that, then I get to 66 millimeters, which means that the point on the enlargement is going to be exactly here. So if I take that away, I can put my cross where it needs to be. And you can follow that process for each of the 3 corners of the triangle, and it will successfully give you the enlargement. You will notice this bottom point is of course on the same line as same corner of the original triangle. The top point will be on this line here. In fact, let's go a stage further. Let's look at the top point here. Again, 0 is on the origin. I'm going to turn it up and we will look at the distance there. It is this time 36 centimeters, so you would have to go up to 72, which would take us there. So again, on the line, your corner is going to be there. Now, once you have these 2 corners, you can of course complete the triangle. We know that this side of the triangle is going to be vertical, and we know that this side is going to be horizontal, and we know that these 2 ends join together. So that would be your triangle. Now I'm going to take that a step back because I'm going to do this without the ruler. Let's have a look at what's actually happening here. Again, let's have a look at the bottom corner of the triangle. If we look at its position in respect of the origin, we need to look at the vector in which it's travelled. So it has moved along the x-axis 4 and up the y-axis 1. So the vector of that particular corner is 4, 1. We are using a scale factor of 2, therefore we're going to double it. So that particular corner becomes 8, 2. I am simply multiplying both numbers by 2. So that means my corner is going to be here. The top corner here, again from the origin, has travelled 2, 4. So that is the original vector. It's 2, 4. Again, I'm going to multiply those by 2. So I'm going to get 4, 8. So that corner of the triangle is going to be 4, 8. Again, it's on the line here. Let's have a look at the third point here. the one closest to the origin. The vector there is 2, 1. Therefore, I'm going to double it to 4, 2. That means 4, 2. This point of the triangle is going to be there. I'm going to connect all the points of my new triangle, and 1, 2, 3 sides. So each point of the new triangle is twice the distance away from the origin, and if you count the squares, each side of the new triangle is twice the length of the old one, and we have enlarged it from the origin, the center of enlargement. Let's take a look at a slightly different situation here. We now have a new triangle, and we are told that the center of enlargement is not the origin, it's at 511, so I've marked it on the graph here. I'm also told that the scale factor is now 3. That tells me two things. The new triangle will have sides which are 3 times larger than the original, and it will also be 3 times further away from the center of enlargement. I'm not going to draw the lines on this time. Let's just do this using the vectors. So the first point of the triangle here, let's use this left hand corner. From the point of origin, we need to look at its vector. Well, it's gone along the x-axis -1, which takes us to here, and then down 1, 2, 3, 4. So that is a vector of -1, -4. We know that the scale factor is 3, so I have to multiply these by 3. So the new vector is going to be -3, -12. Let's travel along that vector then. So we have -1, -2, -3 brings us to here. We are at 11, so if we go -12, it's going to take us down to -1. Okay, the second point on the triangle, let's use this one. From the center of enlargement, we are now going up 2, and then 1, 2, 3, 4, -4. So this has a vector of 2, -4. Multiply them by the scale factor of 3, we're going to get 6, -12. So our new journey is 1, 2, 3, 4, 5, 6, which takes us to here, and then again we're at 11 up the y-axis, so down 12 takes us down to -1. Third corner is here. The vector from the center of enlargement is 1, 2 again, so we have 2, and this time from here we are going down 1, 2, 3, 4, 5, 6, so that's -6. Let's multiply those by 3, we get 6 and -18. Let's move along that vector. 6 takes us to here. We are at 11, so if we go -18, we end up at -7, which is here. That means our new triangle is going to be these 3 coordinates linked together, and it looks like that. Let's now test it by putting in the lines that I missed out. And if we draw a line from here straight through that corner of the triangle, you can see it also passes straight through the corner of the new one. The same is true of the line going through these 2 points, and our third one through there. Hopefully that is as accurate as I can make it on this diagram. Is the new shape 3 times larger? Well, this side is 1, 2, 3. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it's 3 times bigger. This right hand side is 2, 1, 2, 3, 4, 5, 6. Yes, again, so it does satisfy all our requirements. It's 3 times further away from the center of enlargement, and its sides are all 3 times bigger than the original. There's one more example I just want to show you, which is where the enlargement actually makes the new shape smaller. So here we have a new situation, a new triangle. This time I am reverting back to the center of enlargement being 0, 0, the origin. I've marked it on here. The difference this time is that the scale factor is a half. This means that the new triangle is going to be half the distance from the centre of enlargement, and it's also going to have sides that are half the size of the original. In other words, rather than multiplying by 2, we are dividing by 2. Let's have a look at the original triangle, and I'm taking a look at the vector of the first of the points. It's at 4, 4. If we are going to do an enlargement of a half, we therefore have to divide those figures to 2, 2. Therefore, the new point becomes 2, 2 as a vector from the centre of enlargement. Let's have a look at the next point on the triangle. Well, the bottom corner is at 10, 0. If we divide both of those by 2, we get 5, 0, and that's where the point of the second triangle is going to be. The third point then is at 10, 4. Again, if we divide them both by 2, we get 5, 2. So our triangle is going to be completed with a point there. And as before, we will then put the lines in between those corners. So our final triangle is from here to here, down to the bottom, and joined up as a triangle. We can, if we want to check our accuracy, draw lines through these points, and we can see that indeed they do follow the same lines from the origin. We can also see, if we count squares, looking at this one here, we are 1, 2 diagonal squares away. The original was 1, 2, 3, 4. Therefore, we are halfway from the centre of enlargement. And if we count the sides, the top side of the original triangle is 1, 2, 3, 4, 5, 6. The bottom one is 1, 2, 3. Therefore, it is half the size. So, it's still called an enlargement, but if it's a scale factor with a fraction, a half, or maybe a third, then we are dividing, not multiplying. And that's it, the 4 different types of transformation. I do hope you did find that useful. Get some practice and have a look at some past papers maybe, and look at some typical questions. I think I mentioned subscribing at the beginning, but if you haven't done already, the button is appearing right below me now. And please do have a look at some of the other videos on my channel. Thank you for watching.